All right, everybody. Mr. Couillard here with part two of the Bucket Lab Summative walkthrough. Last time in part one, we looked at the simulation, how to use the Bucket Lab to collect data, and then set up your spreadsheet and format your independent variable and your dependent variable, do your calculations with your unit conversions, and find the average values. So here in part two, we're ready to um, do the graphical analysis. And so I'm going to walk you through that. Again, this is for the practice data from water in a bucket on the planet Earth. So I want to start with our spreadsheet. If we go back, so what I want to do is format our data into two columns. One for the independent variable, which is the volume, and we want that in liters, and one for the dependent variable, which was our force in newtons. So I want to scroll back for a second back to our old data table, and I want to copy this over. So we're gonna go back to the original data table, and I want to copy. And now when you copy this over, you can't just paste it because you would be pasting the formulas. And so I'll show you. So if I just do Control V and copy it, that's no good. That doesn't give us what we want at all. So if I do Control Z to undo that, and if I go into paste, so I go up here to edit. Under paste special, we can paste the values, because that's what we want, is we want the numbers. So if we do that, it will paste in just the values that we calculated in liters from our independent variable. And then we can go back over and do the same thing with our average values for our dependent variable. We highlight just the averages, and then I want to do edit, copy, and then if we go back over to our graphical analysis, and I want to do edit and paste special, and then I want to do values only. Okay, and so then it will give us the numbers that we're graphing in the volume in liters and the force in newtons. So I'm going to do this graph on paper because that's I want to make sure that everybody knows how to do it on paper. If you understand how to make a graph by hand, then I think you can easily translate that into a digital app like Desmos, or creating a chart on the spreadsheet easier. So I want to start with just good old-fashioned graph paper. So what does if we look at the rubric, what does our graph need? Okay, it needs a couple of axes, right? So I'm going to draw in, let's see, a vertical axis and a horizontal axis. I want to leave room and oops, there we go. So at the top, we need to give it a title. So our independent variable usually goes on the horizontal axis. So we're going to do volume in liters. And then our dependent variable, which is going to be force in newtons. And I'm writing out the units so that you understand what they are. If you want to go ahead and use abbreviations, you could use capital L for liters and capital N for newtons. And then we need a title, and the title is always going to be vertical versus horizontal. So it's going to be force versus liters. Oops. Sorry, force versus volume, right? Okay, so there's our title, axes, labels, units. All right, so we've got a bunch of easy points here right off the bat. Now we not want to create a scale, and so we want to look at our data and our volume. So we want to plot our volume. The highest volume we have is 2 liters. So, okay, that should be pretty. So let's look like we have plenty of room here. So if I do, looks like we have about at least 20 squares. So if I do 10 squares per liter, so I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that will be 1 liter. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that will be 2 liters. Plenty of room, and so then I can do 5. 1, 2, 3, 4, 5. So that's half a liter. 1, 2, 3, 4, 5. 1.5 liters, and like that. Okay, and then we can go in and add the other subunits as needed. Okay. For our forces, let's see, for this data, now your data may have a different max force depending on what planet you're on, depending on the density of what's in your bucket. But for this data, for water on Earth, our largest force is going to be 21.04 newtons. So, and again, I think if we do 20, 1, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20, we're a little bit short of 1 square per newton. So why don't we cut that in half? And so won't we do 1 square for every 2 newtons? So if we go up by 2, so we do 2, 4, 6, 8, 10. And you probably could have made a better use of space if you'd figured this out ahead of time. 12, 14, 16, 18, 20, 22. So 20. So 20 newtons there, 10 newtons there. We're going up by 2s each time. Okay, so that gives us a scale that will fit our independent and dependent variables up to our max range. All right, so now we want to go ahead and plot our data, and this is going to be really exciting. Okay, so these are going up by 10. So if I go to 0.25 liters, which is going to be 1, 2, 3, 4, 5, 2. So it's right here. So 2.5 liters, and then almost 4 newtons. So 2.4, just about. So we'll put it right about there. So that's our first data point. And then we're going to go to half a liter, 0.5, and we're going to go up to 6. So 2, 4, 6, 6.2, just beyond that, right there. And we're going to go up to 0.75, so 0.6, 0.7, 0.75 is in the middle. And we're going to go up to 8.8, so we're kind of right a little bit shy of halfway there. We are going to look at 1 liter. 1 liter is going to be at 11.24, so if we go up here to 10, 11 is halfway, so right about there. Okay. And next one, 1.25 liters. So 1.1, 1.2, 1.25 would be the halfway. And we're going up to 13.676. So 10, 12, 14. So between 12 and 14, almost to 14. So right about there. Next one is 1.5 liters, and we're going up to 16.1. So this would be 10, 12, 14, 16, right there. 1.75, so 1.6, 1.7, halfway is 1.75, and we go up to, so if this is 20, we're going to come down to 18, so it's a little above 18, right about there, and then 2 liters, and that gives us up to 21. So 2 liters is here, 20 is here, 22 is here, so about halfway. It's 21. Okay, so there are our 1, 2, 3, 4, 5, 6, 7, 8 data points. All right, I want to go ahead before I forget and add in the point protectors. So these are just shapes you use to identify all of your data points as belonging to the same data set. You can use circles, squares, diamonds, triangles. I'm gonna use squares this time. So we'll purple squares. And this just gives a good visual quality to your graph. Makes it more interesting than just a bunch of. It kind of dresses up the data points a little bit. Makes them a little bit, a little fancy, maybe. Anyway, all right, so now we're ready to do our line of best fit. So you need a straight edge, if you have it, or a side of a book or notebook. And so now what I'm looking for is trying to angle the ruler or the straight edge through the middle of the points. So like get as many points on the line as you can, and then everything else you want some below, some above. Which, if you don't have a clear ruler, is not that easy. Okay, and then just hold everything still and just draw your line. And again, this is going to be somewhat, yeah, that's probably not the greatest. Probably got more below the line than I did above the line. So yeah, ideally you want to draw straight through the lines, and then yeah, straight through as many lines as you can, or as many points as you can, and then if the data is kind of more scattered, you want to aim for half above and half below. But well, we'll see how good my graphical analysis is. Yours is probably going to be better than mine is on this, based on that line. So, all right. So we have our graph formatted. We have our labels, title, axes, scale, data points plotted, point protectors on our data points, trend line on the graph. We're on the home stretch here. So now we need to create our equation, right? Our mathematical model, our equation for this trend line. So to do that, we need 2 data points. So I want to look at the trend line, and I want to find 2 spots where it crosses the grid, and that will kind of give us an indication. I think if we go all the way back to the axis here, that might be, so that, let me use a different color here. Okay, so this is going to be V1 for volume, and this is going to be F1 for force. So that's going to be our first data point. And then where else is a good, do we get going kind of right through one of the grid lines? Maybe this one up here. Either this one or yeah, let's go ahead and use that one. Even though that's kind of way off the scale. I could extend it out, but let me see if I can find something that's a little easier to read here. You know what? That one right there is not bad either. So let me use and assume if you've drawn your line straight, it doesn't matter how far up the graph you go. The slope of the trend line is going to be constant no matter what. Okay, so we have our 2 points. Let's get some values to these points. So let's see, F. So this is, so our first one is going to be 0 milliliters, and what's that? 2 newtons of force. And then our second point is 2, 4, 6, 8. No. What's this? 0.1, 0.2, 0.3, 0.4. So 0.4 milliliters and 2, 4, 6 newtons. Okay, so now we can go ahead and calculate our slope. So our slope is going to be the change in the vertical over the change in the horizontal. So it's going to be the delta F, change in F over change in V. And we're always, if it's changed, we're always going to subtract the first from the second. So we're going to do F2 minus F1 divided by V2 minus V1. So just like if you were doing this with x's and y's, it's the same thing. Okay, and so then we plug in our points. F2 is 6 newtons minus F1 is 2 newtons, and then divide that by 0.4 milliliters minus 0 milliliters, which is equal to 0.4, right? So then we end up with 4 newtons on top, 0.4 milliliters on the bottom, and we end up with a slope here of 4 divided by 0.4. There are 10 0.4s in 4. So we end up with a slope of 10 newtons per milliliter. Okay, so that is our slope. Our intercept appears to be, so our initial force, intercept is going to be, we'll call it 2 newtons, since that's where it crosses the line. So last step, we want to create our formula for the trend line. So we're going to use the generic equation for the line, y equals mx, m for slope, plus b for intercept. But then we want to turn this into a physics equation. So we don't want to just stick with x and y. We want to use what we're using for variables. So y, we're going to use F for force. And then the slope we found up here is 10 newtons per milliliter. And then the horizontal variable is, we'll say V for volume, and then plus our intercept, which is 2 newtons. And that is our final answer for the equation of line. Okay, and so that is our complete 100% A plus graphical analysis of this data. So, how did you do? If you collected this data on your own, if you took the averages, did all the conversions, how well did you do? I would don't forget to look at the rubric that we're going to be using um, to do the scoring for this. But yeah, so if you can do this, if your results are very similar to mine, then I would say you have a high degree of confidence going into the Bucket Lab Summative next week. So that's it for part two. Let me know if you have any questions about doing the graphical analysis. And I will talk to you soon. Thanks.